Hello everyone and welcome back to our channel. In this video, we will be talking about the Numpy library of Python. Numpy stands for numerical Python. It is a Python library for scientific computing used for manipulating large arrays of data in a faster and compact way. The Numpy arrays and matrices can have different data types also. This allows the code to be optimized even further. With that, it is worth mentioning that just like pandas, NumPy is a fundamental library or package that one must learn to work with data in Python programming language. In this NumPy tutorial, we will be using Colab as the IDE to run the code and see the results in real time. But before we go ahead and do the implementation, install NumPy and import it into the Google Colab environment, let's have a quick view at the official website of NumPy, which presents the documentation and relevant details related to NumPy. The current version of NumPy is 1.25. As we go further in the future and as we progress, the more recent versions of NumPy will come up. Then if you want to check out further documents and all, you can check out this website numpy.org yourself, and you will get a user guide. You can get getting started, you can get API reference, contributors guide, etc. with all of this stuff. Now, what is NumPy? NumPy arrays have a fixed size at creation, unlike Python lists, which can grow dynamically. So there are certain advantages which NumPy has, uh, which is why it is preferred a lot in data analysis and machine learning. They facilitate advanced mathematical and other type of operations. Yes, you can do a lot of mathematical calculations with the help of NumPy arrays. A growing plethora of scientific and mathematical Python-based packages are using NumPy arrays. That is, this is the basic library that people are using to develop more libraries or more packages in Python. Alright, so the rest of the documentation, why is NumPy fast? It is because of vectorization and all. You can read the other documentation so that you have a better understanding of the NumPy library. We are now straight away going to do the implementation part. Alright, let's dive in. Just as we did for the pandas library, we are first of all going to install pandas in our environment. Like we installed pandas in our environment, sorry. We are going to install NumPy in our environment. But because Colab has the advantage that a lot of dependencies are pre-installed, you will see that it is pre-installed and the requirement is already satisfied in my case. Okay. So we are going to type !pip install NumPy so that if any new version is available, that version would be uh, like downloaded in the Python environment. Then after see here, it is giving requirement already satisfied. After we have installed NumPy, we are going to import NumPy as NP again, like we imported pandas as PD. PD was the alias there. Here we are importing NumPy as NP is the alias. Again, the advantage of using an alias is that you don't have to write NumPy every time. You can write simple NP, and that would mean NumPy for the compiler or interpreter. Then the very first thing that we are going to do using the NumPy library is creating a NumPy array. For that, we are first of all creating an object A which has three values 1, 2, and 3, and we are executing this. Then we are going to create a NumPy array in the variable B which has the values of A, and then we are going to print B. Now, this is an array with the values 1, 2, and 3. Got it? This is a simple way in which you can create a 1D array. Now, arrays can be two-dimensional, arrays can be three-dimensional also. How we can create a 2D array? Let's see. For example, we have a variable C where we are giving two square brackets. Okay, the first square bracket is the main one. Okay, just like we gave here. Now, inside this square bracket, we have given two more uh, square brackets. Okay, this first one, this is the first element of the two-dimensional array, this is the first row, and this one is the second row of the two-dimensional array. After we execute this and we print this, you can see it will come down as a two-dimensional array. See, we have two rows. This is the first row, this is the second row that we specified. So this array is a 2D array because it has two rows, two dimensions. Now let's create a 3D array. 3D array we are storing in the variable d, and again see, 2D array we had two square brackets in the starting and two square brackets in the end. This is one way you can recognize the array dimensions. Alright, for the 3D array we have three square brackets in the starting and three square brackets in the end, okay, inside the parenthesis. Now we are giving 1 2 3 as a first object, 4 5 6 as a second object, and 7 8 6 is as the third object, 7 8 9 sorry, as a third object. Now these will be appearing in three separate rows of this numpy array d. Let us execute this and let us then print d. Okay, we could also written print d or print c here, but it doesn't make a difference. You can straight away print it. Okay, if you will print, the only difference that comes, I can show you here, is that the term array will disappear. That is the only difference you get. Okay, otherwise this is a three-dimensional array, this is a three-dimensional array. Three-dimensional means it has 1 2 3 rows. Okay, and each row is having three objects, elements in it. Now let's see how we can find the dimensions of the array. The 1D array we stored in the variable d. So first of all we are going to do b.endim and we'll see the dimensions of it. Then we will do c.endim to see the dimension of the 2D array, and sorry, endim, c.endim, and then we are going to find the dimension of d.endim of the 3D array. Now see, because this was a 1D array, so it gives the dimension as 1, right? B, the b variable is here, this. Since it has only one dimension, it is having only one row, you can think of it that way, so it is showing as 1. Then you have the c variable which has two dimensions, so it is giving output 2, and d variable which has three dimensions, so it is giving the value as 3. Then you calculate the byte size of each element. Now what is byte size? Byte size is the memory space occupied by each element in the array. So for example, we want to check the byte size of every item in the b array, which is one dimensional array. It is 8. Now let's check it for the sake in the second array that we created, which was a 2D array c. In that also the byte size, that is the memory space occupied by each element, is 8. And in the 3D array also, let's check it. So it is d dot item size, the value is 8. Okay, so this is how you can get the byte size. Supposingly you want to see how much memory space a particular array is occupying, this is the particular command that you can use. Then you want to know the data type of the elements in an array, the command is simple, b.dtype, just like we did in pandas, right? Similar way you can type array.dtype, and then it gives you the data type. Data type is integer 64 because all the values were numeric. Okay, none of the values were float. But for example, let us define a new um, let's say array e and numpy dot array, and here the value is 2.4, 5.6, 7.8. Okay, let us define this new array, and then we find out e dot d type. Now it is going to give you the data type as float because all of these values are in decimals. Got it? Okay, let's check one more thing. Let us create another array, np dot array, where create a new we create Tommy and Kelly. We give two of these variables. Okay, let us keep we are giving string type of values and creating an array with that. And then let's check the d type of it, f dot d type. Okay, so this is giving d type u5. U5 means it is Unicode string type, string data type, where elements are there in this array, and 5 means that the maximum length of the element is 5, that is it is less than 5 characters. Every element in this array is less than 5 characters, like Tommy also is 5 and Kelly is also 5. Okay, for example, if I add here some other term, or like say Sylvester, Okay, and then now we check it. So Sylvester is 1 2 3 4 5 6 7 8 9 characters, so it is giving less than u9, that is the Unicode 9 format string type. Variable is there, are there in the elements are there in the data array, and it is less than u9, that is the character length is less than 9. Got it? So this is how you can check the different uh, data types of the elements within the array. Fine, let's check the shape of the array. Okay, b dot shape, which is 3, and it is not giving anything on the other side because this is 1D array and it has only one row, okay, which has 3 elements. Then c dot shape, it is a 2D array, so this has 2 rows and 5 columns. Okay, so that is why it is giving 2 comma 5, 2 rows with 5 elements each, sorry, 2 rows with 5 elements each. Then d dot shape, which is a 3-dimensional array, this has one layer with 3 rows and each having 3 elements. This is how you can interpret the shapes of the 1D, 2D and 3D array. Now suppose you want to get the particular value in an array. Okay, to get that you can print, for example we want to print b of 0 comma 1. Okay, so this will give you the value in the zeroth okay, array is one dimensional. Let's check it for C. Okay, this gives you 2. This is why let's print C once so that you can I can explain it to you. In C, at the this is the zeroth location, and zeroth location the first element is 2. That is why it gives you 2. Okay, this is the zeroth row, and in the zeroth row the first index location, this is zeroth index location, this is the first index location. So in the zeroth row the first index location is 2, that is why we got the output as 2. For example, if I change here, I make it the first row and I want the second index location, then it will give us the output as 8. See, got it? So this is the first row and the second index location is 8. So this is how you can get a particular value in the array. Alright, so this is pretty much it for the part 1 of NumPy, and I hope you've got a good understanding of how you can install NumPy, how you can import it, and how you can do some quick commands related to it. We will be talking more about NumPy in the videos to come. Till then, keep watching, keep sharing, keep recommending it to your friends who want to learn machine learning and data science, and don't forget to subscribe if you haven't.